I'm David. I work at ANWB, which is pretty old Dutch company. And besides everything else, we also make mobile apps. And today, I would like to talk about mobile app architecture, which is a challenge we also facing at ANWB. Does anyone know what this is? This basically illustrates the problem. It's a iOS architecture name generator. You basically hit the button and you got some sort of architecture. The the thing is, there are so many. There's a Viper, MVVM, MVC, and all these kind of things. And especially for newcomers, this might feel really confusing and hard to approach. So in today's talks, I would like to talk about this a bit. I will also talk about ANWB and how we are approaching this right now. I'm also going to show some code samples. So it's not going to be just ANWB marketing talk. So about ANWB. Our company is really 135 years old. We didn't make any apps by then. We did some other stuff. We also have helicopters, we have roadside assistance, we have mobile apps, we do travel, vacations, all these kind of things. Just out of curiosity, how many of you know ANWB already? Wow, it's almost disturbing. Yeah, so we have 4.5 million members. These are people who are paying for roadside assistance. Unfortunately, not all of them uses our apps, but some of them do. So we're trying to get that number higher and higher. About our apps, we currently develop apps in-house. We basically have 2 teams maintaining about 5 apps. We have also other apps developed by other agencies. But basically, strategy of my department, where I work at App Center, is to bring all these development in-house, so we create more ownership over their applications, and also we are able to release faster and maintain our apps better. This internal initiative started about a year and a half ago, and this also comes with a challenge, because we have so many apps that has so many different architectures, so many different code bases, and we need to find a way how to pull them together and how to be able to maintain them. So our native apps, we have our biggest app is Onderweg app, which has like 500,000 users monthly. It's for paying for a parking as a park mobile, also for checking the traffic information, things like that. Our second biggest thing we have is Wegenwacht, which is roadside assistance. So when your car breaks down, you go to the app, they will come and help you, hopefully. All our apps are native. We use Swift, we use Kotlin. We still have some Java code base. We almost got rid of Objective-C. We just have one app that still uses Objective-C, so this is going pretty great. Besides that, when we brought these apps to build them in-house, we need to figure out some sort of requirements, what we want from our apps, how they should work. Basically, what we found out, we need to support constant change. We also need to make our apps testable, because we want to release often, which is the next point. And what we found out is the only certain thing we got in ANWB about apps, that everything changes all the time. So we needed to architect our apps in a way that supports this change and supports this testing. Basically, only certain thing is, there's no certain thing. So to do that, we inherited all those code bases from all the agencies and all other third-party vendors that worked with ANWB. So what we needed to do first is to look at requirements and look at the code bases that we currently have. The code bases were very, very different, but we tried to approach it in a way that when you only blocking thing that would cause rewrite of our code base is when you cannot add new features. That's basically one main driving thing. If you are too scared to touch your code base to change something, there is a problem and we need to do something about it. So we did this sort of assessment. For some apps, we had bigger problems than for the others. Some apps were okay, some apps weren't. But all these theoretical things are coming to that architecture that we finally started experimenting with in the end. The next thing is about the architecture itself. One of the challenges we are facing with is constantly changing teams. We also still hire some people from some other agencies. So one of the main things about this is it should be easy to learn. What we say, you should be able to explain how we build our apps during the elevator rides to your work, or just draw it out on a napkin. We don't want a really complex, hard learning process. Another thing is high testability. We don't want to spend too much time doing manual testing. We don't want to be scared when you refactor some stuff. Another point is single responsibility of things. It might sound pretty vague, but this basically means when a new person comes to your team and starts working on something, he should look at it and he should know where to put stuff. Where do you put your navigation? Where do you put your view models? Where do you do your networking? This should be pretty clear so we can move faster. Another point is causes excitement. If you do something that people don't agree with, they won't do it. That's what we learned. If we have something complex that all people don't feel ownership about, it's just going to be another annoying thing you have to do at work. What we're trying to do to bring everybody together to work on this together, so we really feel like this is ours. Last but not least is applicability to legacy system. If you have a greenfield app, you can choose any approach you want, any approach you and your team members like. But the thing is, most of the development is not greenfield apps. So if you want to do some changes to improve testability, improve learnability, we should be able to do it on our legacy system. So the next thing I want to share is the thing we are experimenting with right now. I call it MVP+, but we can generate another shortcut if we get rid of this one. Basically, what this is a variation of MVP pattern with higher testability, with dependency injection of each component that helps with that high testability. We can apply this on Android and iOS, so we have kind of similar structure and similar code base on both platforms. So it helps developers to actually switch platforms, which is something we also want to do. And it also defines your app structure, so you don't have to dig through folders with meaningless names and these type of things. The next part I want to really talk about code-wise, how this looks like, how this actually works. There's a few key components to this. Views, presenters, optional navigator, this scary sounding thing called assembly. It's not a language, don't worry, and an interactor. In the next few slides, I would like to go through each one and explain why we do it like this and why it actually makes sense for us. So this is how it's wired together. I'll try to. You see that in the middle, you got a view that's basically an interface. In reality, this is basically interface for either UI view or view controller. That interface is there to help you test stuff. Because you see on the right, there's a presenter that's basically sending data to your view to render them. What we also do here, you might notice the flow is quite unidirectional. The presenter talks to the view talks to the presenter. There's no like two-way binding or things like that. This allows us to write really efficient and easy tests. On top, you can see the navigator. This is basically sort of what it does. It helps you to navigate from one screen to another. Let's say you have a to-do app, you have a list of to-dos, you tap on one. So when you tap on one, this is going to be action called on a navigator. And this thing on the right, the assembly, is basically a factory that wires all those things together, and that's what defines your application. Assembly also creates hierarchy in your application, so it defines your object tree. But I'll show some code samples with this, so hopefully it's become more clear. So the view. The view simply allows you to display things, which we probably all know. In our case, it's an interface. It's either view controllers or views. And more also importantly, it should not know about UIKit. If your view doesn't know about UIKit, it's way easier to test for you and way easier to refactor your applications. In practice, it could look like this. This is like really example made for presentations, so there's no async stuff and things like that. You see that you have one protocol that can show to-dos. In your view controller, you implement this protocol, and when something calls it, you just show to-dos. It's as simple as that. Unidirectional, really clear. The next part is the presenter. Presenter can receive UI actions from a user. So basically, when a view controller loads or user presses the button, the view controller informs the presenter about this action. Then in a presenter, you have logic implemented that handles this action, and the presenter sends display events to your view. If you look at the code for this, you see that you have a weak variable of your view in your presenter, and a method called didLoad. Your presenter is owned by your view controller. So basically, when your view controller didLoads, it calls this method didLoad. You can call it whatever you want. But what it does, it asks your repository to retrieve some to-dos. Then you get the to-dos, then you show them on your view controller. It's really simple example, but the cool thing about it is the testability of this. Because your repository is an interface, and your view is an interface, you can start writing tests like this. You can, you can basically have a mock repository, which sort of mocks your data source. You have your presenter, and in a setup, you see I create new mock repository, and I instantiate my real presenter with the mock repository. Then in our test, you see that first we verify the initial conditions. So initially, maybe a little explanation about this verify method. It's basically a method we made. It just makes sure that the method on an object was called. That's all it does. It just returns true, false. Either get all to-dos was called. If it wasn't called, it returns false. So first I verify that the method wasn't called. Then I called presenter didLoad, and then I verify again that my method actually was called. It's really simple way of unit testing. You can also do TDD with this. When you're developing logic like this, you can simply do it like that. But the thing is, this is just one part. In this part, we just make sure that your presenter calls your repository and retrieves the data. If you look at more realistic test, which also includes the view, because view is also an interface, you can create a mock view. So basically, in my presenter, I instantiate and insert a mock view. Then in my test, I simulate didLoad condition. I verify if all to-dos were retrieved, and I also verify that show to-dos on my view was called. So in this case, you can be sure that those two methods were called. What it's helpful with, imagine you want to refactor your presenter. You can totally change your file, use it, and you just run your unit test, and you are still sure everything works. You don't have to worry about tons of manual testing and things like that. The next. The next thing is the magic thing we called assembly. The purpose of this is wires those things together. We talk about presenters, navigators, and views, but in reality, if you really want to put it in some application, you need some place that actually wires those things together. We call it assembly. We also saw online there are some alternative names, but we kind of stick with this. Another use case of assembly is actually that it creates other assemblies. That's what creates your app structure. And simply said, it acts as a factory for view controllers. Because it's wiring everything together, it just gives you view controller that can be immediately rendered. And assembly tree defines your whole application. So for the example, you see in this assembly, I have a variable with the navigation controller and a variable with the to-do repository. You can see that both of those things are interface injected in this assembly. That's also because you want to test your assemblies. So you can just use interface injection to to simply do that. Then the second method to do view controller is basically that factory method I'm talking about. The first thing you do, you instantiate your presenter. You instantiate your presenter with the repository that's already injected in this assembly. After you have a presenter, you can instantiate your view controller. And then you simply return it. So this is how your hierarchy of assemblies could look like. Basically, as you're returning view controllers like this, you can also return other assemblies like this. And this actually helps you to structure your code in some more meaningful and logical way. What is really good idea here is basically to group things by functionality. So if you have things that are tour related, put them in a tour assembly. If you have login related things, put them in a login assembly. And the tree in reality could look like this. That you basically have it's really simple example. So you have a login assembly, you have traffic assembly, and a core assembly. Core assembly is something that gives your root view controller for your whole application. So what you have in this assembly is basically two lazily created other assemblies, one for login, one for traffic. And your root view controller, which is actually assigned to the root window of your application, just picks one from those assemblies. And other navigation and other creation happens in a traffic assembly. I have a second example about this, because this is the most unknown part of this MVP thingy. This is from a demo to-do app we have. You see that in the app delegate outside, we have this core assembly variable, which is basically you need some place where you instantiate your root thing for your whole application. Then in application did finish launching, you see that only thing that you actually really do is you assign root view controller to core assembly root view controller. Now, imagine you have an application that has some tour and some dashboard. If user installs your application for the first time, you want to show tour. Otherwise, you want to show dashboard. With these assemblies, you basically have your tour in your core, and you have a to-do assembly in your core. So in this computed variable for root view controller, you basically ask your repository, hey, is this the first new install? In that case, you return tour view controller. Otherwise, you return to-do view controller, which is normal dashboard. To test this, it's also pretty easy because all dependencies that assembly uses are injected through its constructor. So what only thing you need to do is to have some mock state repository in this case, which basically just says, yes, this is a new install, or no, this is not a new install. Then you instantiate root assembly with your mock state repo, and you can simply assert, hey, my new root view controller is going to be tour. In a case of a second test, my root view controller is going to be to-do list view controller. Is this clear? Okay, see heads nodding, so that's good. Okay, now the Navigator. It looks the simplest and it's the trickiest. Basically, your Navigator is part of your presenter. Imagine user clicks on a to-do in a to-do list. Your presenter receives an event. Hey, your user clicked on a to-do with ID 4. And your presenter then talks to Navigator to figure out what should happen next. Where should I go? The implementation of a Navigator, if you remember, the assembly is also factory for all your view controllers. So it actually makes sense that the Navigator should be implemented by your assembly. So in this case of a to-do assembly, you see that we can create to-do view controller or to-do detail view controller. When user taps on a to-do in some to-do list, you want to go to to-do detail view controller with some ID. So in this extension of a to-do assembly, we are implementing to-do list navigator, which is this simple interface. And what it does, it basically gets a view controller, which is to-do detail view controller, which is constructed by the assembly itself. It just gives it ID, and it pushes it on a navigation stack. Also, one thing to remember that the navigation controller is a part of an assembly. And in this case, we are basically propagating navigation controller from your root to other assemblies. Okay. And of course, the test for the navigator, you basically create a mock navigator because your interface is really simple and really readable. You can do similar verify test as we did with the presenter. So first you assert that show to do detail was not called. Then you call presenter on to do tab with ID 4. And then you verify that this method actually was called for sure. If some of you are into Android development, it's very similar what the Mockito does. In iOS, unfortunately, you have to write that verify thing by yourself, which is not that much fun. Yeah, another thing I want to talk about is the optionality of a component. Like this whole thing is pretty, it looks clear, like it's stuff you read on a website. But in reality, if your screen is just a text and a button, you don't need all of that. You just need something really, really simple. Imagine you building this. It's info page, and you just read it, and you hit the blue button, and you just close it. In this situation, you probably don't need Navigator. You might not even need a presenter because it's just a simple page with the close button. But what helps is that assembly is factory for view controllers. So you can basically create view controller like this, still in your assembly, but you don't need all the components. That's also one point I mentioned earlier, that this should be applicable for legacy systems. If you start applying this to some system that has sort of architecture and sort of a pattern, you can still instantiate existing parts of that system with assemblies. It basically masks away your, it isolates your old code base, if you will. But it also means you don't have to implement all those components every single time, because it just leads to confusion. If you have a screen with a text and it has a navigator, view, presenter, and all those things, you're just making things more complicated, not easier for people to understand. But what's really hard here is to find that line where it's too complicated and when it actually makes sense. Another thing, this is more like a sneak peek that helps us to improve our testability and our application, is a state problem. Like most average screen in any app can be loading data. It probably makes some HTTP request. That HTTP request can fail, of course. And there's some sort of initial state when the view controller is initialized and actually displayed. These state representations might lead to confusion, because what might happen to you, or maybe you've seen this in multiple code bases. Let's say I still have my assembly architecture. I still have a protocol called to-do detail view. I can show to-dos, I can show errors, or I can show loading indicator. What often happens is that you find a view controller that has these type of variables. You have isLoading variable, true, false, optional error, which is either has a value or doesn't, and optional data because you are waiting before your data loads, maybe. But the problem with this, if you start reasoning about it, what you would do if your error has a value and your data has a value as well. In that situation, you need to start thinking, okay, what situation and what state I'm now? It's the same thing with the loading and the data. What if you are loading and you have a data already? It's really hard to test and hard to reason about, and very error prone. Luckily, Swift enums are here to help. What you can do, you can represent state of your view controller with enum. We call it view state here. Basically, what this enum has is generic parameter t, which is for your data, and it has 4 cases. It has initial state, loading state, data state with associated value of t, and an error state with any error. If you think about the protocol to represent this, it doesn't have three things like this, but it has just one thing. You basically just need one variable called viewState with a given data type. And when you want to set your state, you just implement it on your view controller, and you handle these changes in your did set. So by using this, your state management became way easier and way more testable, because this is much easier to test than if you try to test these four variables. For two booleans, you already need more than two test cases. But if you're starting testing with enums, your view lifecycle becomes really simple and really easy to understand. Okay. The next thing I want to mention is how we approach the view models. View model from MVVM can do other stuff than just display data. But in our assembly architecture, we have a view models that has no logic. They are really plain data object that just hold values that are formatted and ready to be displayed. This formatting or a view model creation usually happens in a presenter layer or in an interactive layer if it's something more complicated. And we also really like did set that helps with the view models and everything. So imagine you have sort of a to-do app. There's a formatted date and a content strings. What we do, you basically, through your presenter, you push this view model to table view cell, and in your did set, we just display stuff. What this helps with is also reasoning about the application. When you get somebody new and when somebody opens it, this is really easier to reason about than updating all the labels and data separately. This really proves that it cleans our code base and it helps. Also, the one other thing is gradual refactoring. Like, we all want to refactor our apps to be really perfect, but if you think about it, nobody will give you 3 months to rewrite everything and don't do anything else. What's possible with this assembly thing is I start doing things gradually. If you imagine you have a massive view controller, Objective-C, 5,000 lines of code, normal stuff, you can easily add presenter to it. And if you already add that presenter, you can just start gradually testing that logic that's in that massive view controller. And if you use something like a Boy Scout rule, hey, if you see something without the presenter, please add it and start interacting with it. You can easily start using that. Actually, same goes for Navigator. If you're navigating from one screen to another and you already moved to your old code base to use assemblies, or at least to be created by assemblies, you can start using a Navigator, and you already have sort of a test suite that actually helps you. Okay. Next thing I want to mention is code sharing among apps. At ANWB, we have 5 apps we maintain actively, and some things are really similar. We have like really simple visual style. For example, our login screens or GDPR screens are exactly the same in all the applications, luckily. So we have some learnings from this. And what we learned is that it's a really good idea to start with interface first, which is documented. And this is where you should start, even when considering building something generic. Just talk to your colleagues about the interface, how we're gonna talk to this. What didn't work for us that well is you start from top down, then you end up with sort of a thing, nobody knows how to use it. The interfaces are really useful. And also, the assembly thing helps us because you basically distribute your assembly, and even if other app is not using this architecture, you can still use assembly as a factory. So you basically say, hey, assembly, give me login screen. Hey, assembly, give me my GDPR permission screen. And you should good to go. But the interface is really important. So I'm a bit quick, but maybe I'll have some time for questions. The main takeaway is, for me, that there's no silver bullet in doing these things. Like, I wish there was one perfect solution that would solve everything, but there's just not. The assembly thing we are doing right now or experimenting with, it seems to be good, but we will probably replace it with something else in the next year where we have some more learnings. It's not our last and not our first thing we are doing. But what we do when we do these experiments, it's always good to keep in mind that you might even change your architecture. So if you're keeping stuff isolated, like in presenters, in navigators, that's something that's probably going to last, but maybe assemblies are going to go away. Who knows? Another learning is that you shouldn't build things that you don't need today. Don't build stuff for the future, because you have no idea what's going to happen. That's something we also learned by building things we think we might be super useful for every other part of our apps and wasn't. Really do stuff that you just need today. And it also relates to the uncertainty thing. Like, you never know what technology will come. Don't build stuff for tomorrow. The uncertainty is still there. And also, last but not least, you write code for people, not for computers. Some other speakers already mentioned, you spend way more time reading the code than actually writing the code. And this is the part where we should really get better and write code that's not just cool, but that's really understandable, that has a good naming, documentation if it's needed. Also, my last point is that good tests are better than outdated documentation. We all want a documentation, but it often happens that you change the logic, but you don't change the documentation. And when this happens, you have even more dangerous things. When you have something that describes functionality that's not in your app. But if you describe your functionality by unit test or UI test, it's always clear how you should use your modules, how you should use any function you have. And that's basically it. Thanks.